Significant figures, problem set 2 and solution. In this video, you will learn how to round off numbers and apply significant figure rules when you do calculations. Round each of the following numbers to the required significant figures. Let's look at the first example given. In this number here, you have 4 significant figures because all the non-zero digits are significant, and this number need to be rounded off to 3 significant figures. When you round off this into 3 significant figures, you will get the answer as 6, 2, 3 and 0. This 0 here is not significant because there is no any decimal place. So you get the answer as 6230. Next one, 0.98029. There are 2 zeros here. When you look at the 0 here, this is not significant. It's act as the placeholder. But this 0 here is significant because it's between non-zero digits. Therefore, you have totally 5 significant figures in this number. Those are 9, 8, 0, 2 and 9. However, we are going to round off this number to 2 significant figures. When you are rounding off, the last number that you are going to drop here is 0. Therefore, your answer is 0.98 with 2 significant figures. If you add zeros after 8, they are significant. Therefore, we do not add zeros when you are rounding off to 2 significant figures. Next one, you have 7, 6, 4 and 5. All are significant. So you have 4 significant figures. You need to round off that to 3 significant figures. When you are rounding off this to 3 significant figures, you are dropping number 5. So if you see number 5 or greater number, you are adding 1 to the next number, which gives you the answer as 7, 6, 5 and 0. Again, the last 0 here is not significant. Therefore, you have only 3 significant figures in the answer. 59.98 has 4 significant figures. We are going to round off that to 2 significant figures, which shows you this answer. 60 is the answer because you are dropping this 9 here, which you add 1 to the next number. And however, there should be 2 significant figures. In order to make this 0 significant, you have to put a decimal place. Let's look at how you use significant figure rules when you do calculations. First one, when you are adding or subtracting, answers are rounded to the least significant decimal place. Let's look at some examples. The first one, 2.34 is going to add to 5.43. Both numbers have 2 decimal places. These are the 2 decimal places in both numbers. So when you add these 2 numbers, you will get the answer 7.77 with 2 decimal places. Therefore, your correct answer has correct number of decimal places, which is 7.77. Next one, 5.65 minus 2.12, which gives you 3.53 in your calculator. However, when you check your numbers, the given numbers, here you have 2 decimal places, 2.12 has 2 decimal places, and now your answer also has 2 decimal places. Next one, 268 is going to add to 672. So there are no any decimal places in both numbers. Therefore, your answer should not contain any decimal places, and your answer is 940. Next one, 1.10 has 2 decimal places, but 8.2 has only 1 decimal place. According to the rule, we are carrying the least number of decimal places to your final answer. So your final answer should contain only 1 decimal place. So if you add these numbers together, you will get 9.30. If you do the calculation in the calculator, this is the answer you get, but with the correct number of significant figures, you should have only 1 decimal place, so your answer is 9.3. 6.78, here you have 2 decimal places, 1.1 has only 1 decimal place. Again, you are carrying only 1 decimal place to your final answer. Even the calculator shows you 5.68 as your answer. With the correct number of significant figures, your answer should be 5.7 after rounding off to 1 decimal place. When multiplication or division is performed, answers are rounded to the same number of digits as the measurements with the fewest number of significant figures. Therefore, when you do multiplication or division, first you count how many significant figures are there in your given numbers, and then you carry the least number of significant figures for your answer. Let's look at few examples. 3.10 multiplied by 2. So 3.10 has 3 significant figures and number 2 has only 1 significant figure. When you do multiplication, you carry the least number of significant figure to your final answer. Therefore, when you do the math here, you get 6.20. With the correct number of significant figure, your answer is 6. 58.60 has 4 significant figures. 2.0 here has 2 significant figures. So the least number is 2 significant figures. When you do the calculation, the calculator gives you 29.3 with 3 significant figures. However, with the correct number of significant figures, your answer should be 29. 845 divided by 45.0. 845 has 3 significant figures and 45 has 3 significant figures. Both are the same. Therefore, we should have 3 significant figures in your final answer. When you do the math here, you will get a long answer like this, 18.77 in the calculator. So with the correct significant figures, we should have only 3 sig figs. So you are going to write the answer as 18.8 by rounding off the answer given in calculator. 6.0 has 3 significant figures and 3.12 has 3 sig figs. When you multiply these two numbers, your answer in the calculator is 18.72, which has 4 significant figures. But you should have only 3 in your final answer, which is 18.7. When you multiply 1.03 by 1.03, your calculator gives you 6.0609. All the zeros here are significant, so you have 1, 2, 3, 4, 5 significant figures in the answer. But depending on the given number, 1.03 has only 3 sig figs, so you need to have only 3 sig figs in your final answer, which gives you 1.06 as the final answer. So this is how you use rules in the significant figure when you do calculations, and when you learn these significant figures, when you do any calculation after that, you have to keep the correct number of significant figures. If you have any questions, please comment in the comment section and I will answer them. Thank you for watching.